This is the key to the worksheet on the intermediate value theorem. And before we look at the first problem, let's just remind ourselves about the intermediate value theorem. So if we have a function that is continuous, I'm using the word continuous in the interval from x equal a to, let's say, x equal b. All right, so this is x equal a, this is x equal b. And let's say when x is a, my point is right here. And when x is b, my point is right here, let's say. Okay, so the coordinates of this point would be a, comma, f of a. And if this is my function f of x, so if f of x is continuous. And then over here, the x coordinate here is b, and my y coordinate would be f of b. So if I have a continuous function, it means that the graph looks something like this, okay? Something like that. So it's continuous from A to B. But the intermediate value theorem says this. So if you do have if a function is continuous in that interval, then every x value in that interval, will have a y value. So there's going to be a point on that graph corresponding to each of those x coordinates. So in particular, if x is c, then there has to be a point that is c, f of c. Okay, so that's what that means. So it could be above or below. All right, so if you look at, so let's say those two endpoints are below the same idea. So this is A, this is B, and we have this point here, and let's say we have this point here. Okay, so if my function is continuous in that interval, meaning there are no breaks or gaps, then that means that for every x value that's in the interval from A to B, every x value that's in the interval from A to B, there's going to be a point on that graph. In particular, if x equals c, then there has to correspond a point c, f of c. So when x is c, there has to be a y value. Now, for this worksheet, though, what we're saying is this. So if I have an interval a to b, from a to b, and let's say one point is above the x-axis, and let's say the other point is below the x-axis, then just in our discussion a while ago, the intermediate value theorem says that every x value in that interval has to correspond to a point on that graph. All right, so you're dealing with a continuous function. In particular, so this is c right here. See where the graph crosses the x-axis? Then if that's c right here, that means that my x-coordinate is c and my y-coordinate is 0. Because remember, wherever the graph crosses the x-axis, my y value is 0, right? So wherever the graph crosses the x-axis, that point there is called a 0. All right, so when x is c, that's where the function is 0. Your y value is 0. So the intermediate value theorem guarantees that if you have in the interval a to b, if at a, one of your point is above the x-axis or below, and at b it's the other way, so in this case it's above, this case it's below, then the intermediate value theorem guarantees that there's going to be a 0 in the interval a to b for that function. And so that's what this worksheet's about. So this worksheet says, use the intermediate value theorem to show that there's a 0 in the interval -2 to 1, -1 for this function. Now here's my function, f of x equal x to the 4th minus 2x squared plus 3x. Now I want you to know that this is a continuous function. All polynomials are continuous. So remember that all polynomial functions are continuous functions. So all polynomial functions are continuous functions. All right. So what I want to do now is use the intermediate value theorem, this idea here. I want to find an x value where the point is above. I want to find an x value where the point is below. then the intermediate value theorem guarantees there's a 0. And so that's what number 1 and number 2 is about. All right, and both of those, by the way, are continuous functions. Those are polynomial functions. All polynomial functions are continuous functions. So what you had to do here, you notice it says show all appropriate work and explain your answer. So you have to find f of negative 2 first. So when I found f of negative 2, wherever we see the x variable, the variable x, I substitute negative 2. So I get negative 2 to the 4th minus 2 times negative 2 squared plus 3 times negative 2. Well, negative 2 to the 4th is a positive 16. Negative 2 squared is 4. 4 times a negative 2 is a negative 8. And then 3 times a negative 2 is a negative 6. Combining like terms, 16 minus 8 is 8, and 8 minus 6 is 2. So what I found is that f of negative 2 is equal to 2. So when x is negative 2, my y value is a positive 2, right? So if you were to kind of look at this way, let me go ahead and do this. So this is negative 1 and this is negative 2. When x is negative 2, I found my y value to be a positive 2, correct? So that means that I get this point here for that function. Then we find out, well, what happens at negative 1? So let's find f of negative 1. So f of negative 1, you do the same thing. Where we see the variable x, you're going to substitute negative 1. So I get negative 1 to the 4th minus 2 times negative 1 squared plus 3 times negative 1. Well, negative 1 to the 4th is a positive 1. Negative 1 squared is a positive 1 times negative 2 is a negative 2. And then 3 times a negative 1 is a negative 3. So when I add these numbers, 1 subtract 2 is a negative 1. A negative 1 and a negative 3 is a negative 4. So I found f of negative 1 to be a negative 4. So that means that when my x value is negative 1, my y value is negative 4. Meaning that, I'm just going to put negative 4 here. Meaning that when x is negative 1, right here, I get a y value of negative 4. So remember, these are polynomial functions, so they're continuous. So meaning that in that interval, to get from this point to that point in this interval, my function is going to have to graph, or the graph's going to have to intersect the x-axis somewhere, right? Okay. So and it should not have gone backwards like this, because it would no longer be a function. So let me just kind of draw it a little bit better, something like this, let's say. All right, but the point is that it's got to cross the x-axis. So the fact that this point's above the x-axis and this point's below, the intermediate value theorem guarantees there has to be a 0, because the intermediate value theorem says if you have a function that's continuous in that interval, then every x value in that interval has to have a point on that graph. So therefore, to go from here to here, it's got to cross the x-axis. And so then you would say this. So then you would say, since something like this, you would say since f of negative 2 is positive, remember it's a positive 2, and f of negative 1 is negative. All right, so remember, one point is above the x-axis, the other point is below, so it has to cross the x-axis. So since f of negative 2 is positive and f of negative 1 is negative, the intermediate value theorem, we'll call it IVT, guarantees that there is a 0 in the interval from negative 2 to negative 1. And you can see that just from here. Now, you're going to have to, now in this case, remember in this problem, you're not interested in what that 0 is. You just want to show that in that interval here, using those ends, the endpoints, negative 2 and negative 1 of that interval, the lower bound, upper bound, you want to show that one y value is positive, one y value is negative, and that will guarantee that there is a 0. But you're not asked to find that 0. All right, you just want to show that there is a 0. And you did that, okay? All right, number 2. So number 2, I could have chosen a better function for number 2. This function made the directions here a little bit more complicated to understand. So, so basically, you're looking for that same idea here. So you have this function, it's a polynomial function, so it has to be continuous. And the question is though, what is the smallest positive integer a, such that the intermediate value theorem guarantees a zero between 0 and a. All right, so if you went ahead and you did f of 0 first, so you said, well, I'm going to find f of 0. I want to show you what's going to happen. So f of 0 would be 0 cubed minus 0 squared plus 2 times 0, right? So 0 cubed minus 0 squared minus 2 times 0, that's just 0. So f of 0 is equal to 0. But remember, 0, the y value 0 here, that's not a positive nor a negative number. It's just 0. But remember, what I want you to use is I want you to find an x, I want you to find a point that's located above and another point that's located below. And then the intermediate value theorem will guarantee that there is a 0 in that interval. Okay, so then let's go to 1. So f of 1 then would be 1 cubed minus 1 squared minus 2 times 1, right? Well, 1 cubed is 1, 1 squared is 1, so I get 1 minus 1, and then a negative 2 times 1 is a negative 2. 1 minus 1 is 0, and then we have 0 minus 2 is a negative 2. So f of 1 is a negative 2. So what I found at this point is this, just to kind of show you something. So I found right now, so when x is 1, I found my y value to be negative 2, right? So this is what I found. Okay, so what I need to know now is what is the next positive number in which my y value is positive? And then if that's the case, then I know that it's going to cross the x-axis. And then this would be a 0. That's what I find. So I'm trying to find this a, such that my y value is positive, because here my y value is negative. This was 1, negative 2. All right, so let's go and now remember they're asking for an integer here, right? So an integer. So let's do the next integer. The next integer is 2. Now here's where the problem arose. So if x is 2, I want to show you what happened there. When x is 2, I get 2 cubed minus 2 squared minus 2 times 2. Well, 2 cubed is 8, 2 squared is 4, and then 2 times 2 is 4, so that's minus 4. So that gives you 0 when you added those numbers. So what you found when you set f of 2 equals 0, remember this is 0, right? So you found that when x is 2, my y value is 0. That's what you found. So with regards, remember this is x equal 1. So what you found is that the graph is going to cross the x-axis at 2. That's what you found. So when x is 2, my y value is 0. But what I wanted you to do, though, was I want you to find the smallest smallest integer a rather, such that since this is negative, then that will be positive, and then that would guarantee. Although you already found the 0, so that's what makes this not a very good problem to use. But you already found the 0. But I want you to find another point that, since this was below, another point another value of a that would make the point above the x-axis. All right, so basically, you really had to go a little bit further. So f of 3 would be 3 cubed minus 3 squared minus 2 times 3. 3 cubed is 27. 3 squared is 9. 2 times 3 is 6. 27 minus 9 is 18. 18 minus 6 is 12. And so we found f of 3 to be 12, and that's the one you wanted. So when x is 3, my y value is 12. So when a is 3, my y value would be 12 here. So that would make this point above the x-axis. And then the intermediate value theorem says that in the interval from 1 to 3, or actually from 0 to 3, there's going to guarantee, the intermediate value theorem guarantees that there's going to be a 0 in that interval. Okay, now let me kind of show you what the graph looked like. So we have this, and I'm going to go ahead and draw this graph first. So let me do this. All right, so this was the function we're looking at. This is what the graph basically looks like. So we know that the graph crosses the x-axis at 2. So there's 1, 0. Here's the other 0, which we already knew, right? We already knew that was a 0 from here. So when x is 0, my y value is 0. So I knew that the graph had to cross the x-axis at 0 as well. But the other 0 is here. So the graph looks like this. There are 3 zeros. remember the degree of this polynomial is 3. So one of the things you learned in a previous lesson was that the number of zeros has to be at most the degree. So there's 1, 2, 3. Could be 3 or less. In this case, it was 3. See, here are the zeros. The degree is 3, 3 zeros. Remember the turning points? So the number of turning points, has to be one less, at most, one less than the degree. So the degree is 3. 3 minus 1 is 2. So you have to have at most, 2 turning points, and you do. You have 1, 2. All right. But anyway, so there's the graph, and what you found is this. In the interval from 0 to 3, the intermediate value theorem guarantees there's at least 1 0 in that interval. And that was when a was 3. All right. So the way I would write this is this way. I would say, so when a is 3, when a equals 3, the intermediate value theorem guarantees that there is a 0 from x equals 0 to x equals 3. All right, so from x equals 0 to x equals 3, the intermediate value theorem guarantees that there's a 0. Now, so the again, as I said, that function was not a good function to use for this direction here. But there's actually 2 zeros in there. So there's one here and one here. But I did not choose a very good function here. So if you had stopped, let's say you found this right here, which some of you did, you said, well, that's a 0. I already found the 0. So if you stop there, I gave you credit for it, although I was looking for something other than you stopping here. So I did choose a bad function for this set of directions. Okay, but if you can do number 1 without too much difficulty, I think you should understand the intermediate value theorem and the applications or the consequences of it, what it means. But that is it. So that's the key to the intermediate value theorem.